All right, so I know I started recording late. Whoever's watching this, I'm going to do more problems like this, but you should be able to figure it out by the picture. Okay, so sine of theta is opposite over hypotenuse. Opposite over hypotenuse. We'll talk about that radical in the denominator in a minute. Cosine would be adjacent over hypotenuse. Now that we're heading towards calculus, in calculus you never rationalize your denominator. They want you to do less work. And so we are transitioning to that at this point where we're allowed to leave a radical in our denominator. Okay? We don't on the unit circle, as you know. On the unit circle, we've simplified them all. And if you remember, I don't have to, yeah, all of our denominators are simplified, right? We have no radicals in our denominator on the unit circle. But when we're working with trig, you can leave the radical in the denominator. But we're still in that transitioning phase, so understand that on an FRQ or like an open-ended question, absolutely leave the radical in the denominator. But you might see in a multiple choice question the solution rationalized. So we learned how to do this a long time ago. I'm just showing you the steps. This is the same as this. Fine to have what I have boxed in as your answer, but be aware of how you would recognize that that's also the answer, right? Like if you get 0.5, you also know that that means 1/2, okay? So you don't have to rationalize it, you just have to know how to do it or recognize it in case it's in a multiple choice question, okay? Does that make sense? Let's do another one. You guys don't have that sentence right there, which is good. I don't want you to have it, okay? Let theta be an acute angle such that sine of theta is 5/6. Evaluate the cosine and tangent values of theta. So in the question before, it was drawn for you, but in the homework it won't be, and I'll do some with you. To get to that point, you figure out what quadrant you're in and you draw your triangle. Well, what if they just give you that sine is 5/6, sine of theta is 5/6, and that it's an acute angle? Just with that information and her hint here, where are all your acute angles? Quadrant 1. They're so cute. They're less than 90. Acute angles are in quadrant 1. So just by saying that, we know our triangle that we're going to draw is in quadrant 1. So we're going to practice drawing triangles over and over and over again. Here's how you draw every single triangle on the coordinate plane. We always start at the 0, 0, duh, right? And then you go out into whatever quadrant we're in. We said quadrant 1. So you just draw your hypotenuse. As long as you want it, short as you want it, we're not drawing to scale. We're going to label it anyway. You always drop down to your x-axis. The right angle is always made with the x-axis, just like that. And then there's a theta. It's always by the origin. You know, triangles have 3 angles. You have to pick where you put theta. It's always, no matter what quadrant you're in, at the origin. And that's important, because now we're going to label the sides with what's given. Again, using SOHCAHTOA. Sine is opposite over hypotenuse. So 5 is opposite, 6 is hypotenuse. Opposite what? Opposite theta. So opposite theta would be here, hypotenuse would be here. What are they asking for? Cosine of theta and tan of theta. So we need our missing side, right? We have the hypotenuse, we have a leg, we're missing another leg. So plug it into your Pythagorean theorem. Show as little or as much work as you want. I get 11 here. I get plus or minus the square root of 11. And you're going to hear me say this phrase a lot, respect the coordinate plane. We are on the XY graph, right? We have to decide every time which sign to use by what we're dealing with. It's not always positive, it's not always negative. It just depends on what quadrant you're in. If we're going to the right from 0, we're going to use which one? Positive, right? We're going to the right. That's positive square root 11. And now we just do our SOHCAHTOA business. Cosine is A over H. This is adjacent. this is hypotenuse. That's the square root of 11 over 6. Tan is opposite over adjacent. And love it, leaving the radical in the denominator makes our lives a little bit easier. But you can rationalize if you want to, either way. Good? One more triangle. If theta terminates in quadrant 3, okay, now we know where we are, and they give us a tan value, find the exact values, no decimals, for sine and cosine. Okay, so let's start by drawing our triangle in quadrant 3. Same thing, start at 0, 0, make your hypotenuse out into the middle somewhere, wherever you want. Always make your right angle with the x-axis, always, always, and theta is at the origin. And tan is opposite over adjacent. So opposite theta is 4, adjacent to theta is 7. But something's wrong. Come on, smarties. What's wrong with my picture? Something's wrong, but I followed the rules. What's wrong? What about them? They should both be negative. Respect the coordinate plane. Respect it. If you go to the left, you are negative. If you go down, you are negative. Why didn't it say it there? Because in reverse, tan of theta, if I said to you, what's tan? You go, oh, okay. Tan of theta is opposite over adjacent. And we always simplify our fractions. So, of course, when you see it written like this, it's because it's been simplified. You have to remember in quadrant 3, this is where students make the most mistakes, is quadrant 3. You have to respect those negatives. It should all work out perfectly, though. Like, it's not like one of them would be negative and this is positive. Okay, so what we need is sine and cosine. We are missing our hypotenuse. Can we skip a few steps? Oh, this one. Negative 4 squared plus negative 7 squared. Now, it doesn't make a difference in Pythagorean theorem whether you have them negative or positive. That's not going to make a difference at all. Because when you square a positive or square a negative, you get the same answer. But when you go to answer your questions, and by the way, while I'm talking, positive hypotenuse always. Okay? But when you go to name sine and cosine, if you had left those positive, you'd have both of these wrong, right? Because you would have had a positive over a positive instead of a negative over a positive. So sine is from theta, opposite over hypotenuse. So that's negative 4 over the square root of 65. And then cosine is adjacent over hypotenuse. And again, you can leave those radicals in the denominator. Good? I'm going to do the first two in the homework with you momentarily. If you want more information about 30, 60, 90, 45, 45, 90, there it is. Moving on to the very last thing. I want to go over quadrant 1 with you. This is quadrant 1. It's all about quadrant 1. If you know, you know. No? Still no on the shirt? Okay. So we're going to do sine, cosine, and tangent, the 3 main trig functions of the first 3 angles, okay? So if you look here, we have 30 degrees, which is also pi over 6, right? Make those mesh in your brain. Come up with the ordered pair in your head, and then look up here and make sure you got it right. So the first ordered pair on the unit circle, right, we start with the square root of 3. Sine is the y value. Cosine is the x value. Don't forget what you know. Tan. Well, tan is y over x. 1/2 divided by square root of 3 over 2. Keep, change, flip, rationalize, simplify. There's our answer. Or, let's remember the trick. If it's a 6, y over 6 is the same as 30 degrees. What is the tan? What? It adds up to 6. So, square root of 5 over 1. Square root of 3 over 3, right? 6 adds up to 6. Now that's not on the unit circle quiz, but you do need to know it. Okay, so 45 degrees, those middle ones, I don't think anybody ever messes those up. All the middle angles. Sine and cosine are the same, unless you change signs in other quadrants. Quick, what's tan? Square root of 2 over 2 over square root of 2 over 2 is 1. 1. That's easy to remember. It's 1. Don't forget it. Okay? And then, of course, this is the flip of our 30 degrees. Pi over 3 and 60 are the ones closest to the y-axis. Sine is the y value. Cosine is the x value. Quick, what's tan? Square root of 3. There's really only these two. You're going to remember 1, even though maybe some of you didn't today. But this is the same as this. And then 6 adds up to this. That's easy. Easy remembering. What? Did you say what? Hi. If you know quadrant 1, guys, all the quadrants repeat themselves. Know quadrant 1, then you can really follow all the patterns in the rest of the unit circle. It's super, super important. You still writing? All right. Homework is 1 through 12. And then I have a special surprise for you before the class is over. If you talk to some of the other classes, don't listen to them. They don't know it's good. You guys know it's good. I'm going to do the first two with you just to make sure you're good. Guys, look. 1 through 4 are drawing a triangle and finding it. Look at 5 and 6. What's different about 5 and 6 is these triangles are not on the coordinate plane. So you know how I say respect the coordinate plane? There's no coordinate plane here. Everybody's positive. So I kind of describe this as drawing a triangle in space, just on a space. It's not in the unit circle or on the coordinate plane. So you don't have to worry about signs when they're drawn just like this. Okay? All right. Number 1, we're given a point, and we have to find sine and cosine of that point. So we're going to sketch a triangle in whatever quadrant this is in. So if we go to the right 3, down 4, we're in quadrant. So here's a quadrant 4 triangle. Start at the origin, draw your hypotenuse or radius out into the middle, make your right angle with x-axis, theta at the origin. How did we get there? We went to the right 3 and down 4. That's how we got to this point. Not drawn to scale, obviously. How do you get to this point? This point is right here. How do you get there? You start here and you go right 3, down 4. Okay? It's your travel distance, kind of. Okay, so guys, this is a 3, 4, 5 triangle. After this, if you remember that, you wouldn't even have to do any work. But I'll just do it real quick. Hypotenuse is always positive. Okay? And it doesn't matter which order you write these. You can put cosine first and sine first. Just make sure you know the difference. So sine is opposite over hypotenuse. If you can simplify the fraction, you would, but we can't, so we won't. And cosine is adjacent over hypotenuse. That's it. Yeah. That's not how it's made. I'll think of a better answer for you. But that's just not how it's made. Oh, because that's not how you travel. How do we get to this point? We go to the right and we go down. That creates a right angle. When you find a point on the coordinate plane, I'll do it right here. What quadrant are we in here? 2. That's important. We got to know how to draw it. So let's first just draw the triangle from the origin just out into the quadrant. Make your right angle always with the x-axis theta at the origin. So the question was, why do you do the x-axis instead of the y-axis? For the reason of this. So again, how do I get to that point? How do I travel from here? I go left 1, up 2. So that, by the traveling of going to the left or right and then up or down, creates that right angle right there. Okay? I never even thought about why, so I'm glad you asked. Okay? So those are our legs of the right triangle. So I changed it to R, C, R, whatever you want to call it. 1 plus 4. So I get plus or minus the square root of 5. Positive. Answer. I switched it up. I put cosine first. Be ready for that. Adjacent over hypotenuse. Leave the radical there if you want. Sine. Opposite over hypotenuse. Okay, I will come around and answer any questions you may have. The last 6 problems are unit circle. Try to do it without looking at your unit circle. Let this be practice for what's coming. Remember, you're not going to have your unit circle on any test. Any of them. You won't be dependent on it. Is that yours behind you? 1 through 12. I know it was useful. Let's put the one on my desk. It was someone that sat there. Or it was your buddies, Levi and Dylan. Remember the day we talked about all that? And I talked about how to make this one. And it's because of my 7th period and 6th there, girl. So she's calm and sits there for you, and she got it and she took it out there. She knew. That would break my heart. That would break my heart if Levi did that to me. Yeah. Like, seriously, you should feel bad. Whoever it was, I'll probably never know, but they should feel bad.